All right, for 56 now, same sort of ideas we had in 55. A plus B to the 16th equals C. Here, type this in your calculator. You can do log of 1 over 216 divided by log 6. You will get negative 3. Same thing here. Log 216 divided by log 6, you'll get 3. Here, 3 to the x. 3 to the x looks something like this, or like this, but the inverse reflects over the line y equals x. This is the only option that reflects over that line. This one does not, this one does not, this one does not. Evaluate log base 7 of 40, same thing, log 40 over log 7. Type it in your calculator, you'll get 1.896. This one is a log graph. Log graphs look like that, something. Move to the left 8. So that plus 8 moves it to the left 8. So I have two options here. So really, this is the one that we have to think about a little bit more. So now if I look at the x-intercepts are when y is 0, not when x is 0. So I know this is not even possibility for x and y intercept. So B has to be my solution without even doing any of the math. Solve the exponential equation. So for number 62, I have 1/9, which is the same thing as 3 to the negative 2, and I have 27, which is the same thing as 3 to the 3rd. Let me zoom in a little bit more. That's out. Come on. Come on. We ain't got much time, computer. All right, so we have 27 as 3 to the 3rd, so I'm just rewriting that. Since the bases are the same, I can take the exponents equal to each other and solve for x. Same sort of deal with number 63. So 63, I can rewrite 81 as 9 to the 2nd. So I have 9 to the 2nd times 9x, and 9 to the 1st essentially. So 2 times 9x is 18x equals 1, divided by 18. 64, I would actually need to rewrite that in log form. Sneeze, don't sneeze. Log base 125 over 150 equals 9x minus 2. So here, I can type this in my calculator as log 150 divided by log 125. Add the 2 over, divide by 9, type it all in. Be very careful how you type it in. And our answer is 0.338. Beautiful. Moving on. Same sort of idea with number 65. We have solve. So I can rewrite this as log base 6 of 32. Type that in your calculator. Log 32 divided by log 6 equals 8x. Divide that number by 8. You get that answer. Same sort of idea on number 66. Log 50 divided by log 10. Actually, log base 10 is in your calculator already, so that's our common log base. So you just type in log 50 divided by 2 and write your answer. Here, the only thing we need to do first is divide by 3 real quick, and then you can rewrite this in exponential form. So again, our base is 10, so 10 to the 4/3 equals 2x. And then write that in your calculator, divide the number by 2, come out with your solution. Here, we already have it in log form, so again the base is 10, so we have 10 to the 1st equals 6x plus 4, solve for x. You guys know how to do that. Here, if our bases are the same, you could also type this in your calculator, but if the bases are the same, it equals the exponent, so that should just be 3. Here we need to rewrite this. Our base is e, so e to the 7th equals 3x plus 1. Type everything in, subtract 1, divide by 3, write your answer. This one, add 6, divide by 4. We need to get it in exponential form first before we do anything. Once we have it in exponential form, I notice my variable is stuck in my exponent, so I can rewrite this in log form. So natural log of 17 over 4 equals 4x. Type that in your calculator, divide it by 4. 0.362 is our answer. 6e to the 2x plus 9. The only thing we need to do here is divide by 6 to get it in exponential form. Once we have it in exponential form, put it in log form. Once you have it in log form, type in ln 5. Subtract 9, divide by 2, get your answer of negative 3.695. E to the x equals 3 over 4. It's already in log form, so I just need to rewrite this again such that the base is e, so natural log base e of 3/4 equals x. Just type in ln of 3/4. Hey-o, that's our answer. Move on with your life. Here, is this direct, inverse, or neither variation? Just looking at our equations, y equals negative 4x. Does that make sense? Well, if I take all of my x values, multiply them by negative 4 times negative 9 is 36, times negative 4 is 28, times negative 4 is 8, times negative 4 is 4. Hey, well, that's my answer. I'm not going to worry about any other option. Suppose that x and y vary inversely, so we have y equals k over x, where k is our constant of variation. Y equals 8/3 when x equals 8, so I need to figure out what k is. So I put in 8/3 for y and 8 for x, then I can multiply 8 to the other side. So times 8 times 8, so that tells me k is 64 over 3. So I have my new equation, y equals 64 over 3 over x. That is the function that models inverse variation. And then it says find y when x is 4. So I can plug in 4 here, 64 divided by 3, enter, divided by 4, enter. You'll get the solution 16 over 3, which is also 5.3 repeating. All right, I'm going to pause it here, and then I'll start another one.